I'm sleeping in like a lot of Mr. Castle. Hey, so if you look up here, discussing tests, we already did that. Then we have SWBA. Student will be able to factor by using the distributive property. Factor by using the distributive property. Do we know what the distributive property is? Yeah, what is it? Okay, when you have something multiplying with something in parentheses, and then you multiply it to everything in the parentheses. I heard multiplication. That is multiplication. Okay, so we have this distributive property. So today we're going to learn about factoring. Factoring, let me plug this in. Factoring is like the reverse of multiplication. It's kind of like division. Okay, it's like the reverse of distributing, for example. So we're going to learn today one method of factoring. We're going to learn a few this chapter. We're going to learn one method of factoring today that is the reverse of distributing.
So I'm distributing.
It kind of sounds weird, right? Okay. So first of all, factors. What is a factor? It's a number and or variable that blinks evenly into a term. Goes. Let's say. Let's say make a more math word. That's less of a math word. Divides. Let's say divides. Okay, let's go for more of a math word there. We often use slang to say goes into. But let's use a math word for our actual definition. Okay, so we can say that as a slang. I'm okay with that. To say it goes into this. But yeah, let's just make sure that we, for this definition, we use the math word there. So factors are numbers and or variables that divide evenly into a term. That should be divide, not divides, excuse me.
I wrote it.
So did I.
Yeah, but you can go back.
Yeah, definitely. Yeah, I got some on my desk, but you can grab one out there either way. There you go. Alright, so, attention back up here, please. Attention back up here, please. Thank you. So, what are the factors of 72? Raise your hand if you give me two numbers that multiply together to get to 72. Grace.
8
and try again.
9.
9. Ben. Is that what you have? Okay, Justin. Okay. Are there others?
Yes.
Okay.
2 times 36.
Very good.
Yes.
Raise your hand if you have another one. 1 times 72. One in itself.
Oh, duh.
Justin.
3 squared times 2 plus times 2 times 4.
Just two things multiplied together.
Oh, I solved it for the prime. Oh, wait, no one knows how to do that.
Okay, yes. Yeah, so we're just saying these two numbers go together. So 8 and 9 are pair factors. 2 and 36. So I write my plus signs like this, and I write my and like this. So this means and this just means plus for me. I heard 4 and something.
17.
Good guess, Josh. I knew it. Just guessing right after everyone else did. Okay. We got two more still.
What the heck?
Wait. 3. Do we have 3? No, 3 times 20.
You're right.
24.
Yep, not as funny as 25. Okay.
Did you write 8 times the scribbly thingy?
Sure. Okay.
Oh
And
my
then,
god, I got 3 out of the 6. I got 50%.
okay.
Oh, you're so good.
What's another one here?
What do you want to
5 times. No, you can't do 5. Oh,
Why can't you do 5? Doesn't end in 0 or 5.
Because it doesn't. Yeah.
Okay.
Yeah.
Yes.
My wife is
6.
that
6
dumb.
times 12.
I remember.
12. Okay. So these are our 6 pairs of factors. There's a total of 12 factors. You kind of need to them up individually, and they are put into 6 pairs. Whatever they multiply with to get to 72. Now we have prime numbers. A prime number is any whole number that's greater than 1, whose only factors are 1 and
0.
not 0.
Itself.
Itself. 1 in itself. So what's an example of a prime number?
7.
4.
Okay, I heard 7. 2. 2.
1. 4.
That has to
One
be
is
greater
not a
than
prime
1
number.
by your definition. 4 is not
Three.
prime.
Three.
2 times 2. 3. What about
Five.
5?
97.
9. 13.
97. That has to be one. It's the weirdest number ever.
61.
Oh, I got him thinking over here.
I'm trying to think if 97 is prime.
I did look at
Hey,
it.
look it up. Here, I'll look it up.
I
for
think
you.
it is.
I'll look it up for you.
I feel fairly certain it is actually.
9. I'm still on the. Wait, no, because 9, 3 times 3.
I'm pretty sure 97 is.
Yeah.
I mean, it's
It's
a-
13, 23.
Yeah,
23.
97 is a prime number.
23 is prime. 25 is not prime.
21.
13.
And 20,
79.
21 is not prime. What goes into 21?
7.
7.
Oh.
67,
13
13,
prime.
57.
Okay. So hey, fun fact. There are
Oh,
infinitely many
golly.
prime numbers. Infinitely many. They're like they literally can't be counted. They
Wait,
go
wait,
on
wait.
forever.
31, 41.
Ability.
Okay, we're done guessing. We're done guessing.
So why is like 7 a prime number, but then if you add 7 plus 7, it's not like 14 is not a prime
Okay.
number.
So
It's
what can multiply to get to 7? Just 7 and 1.
Okay,
But
but
what can multiply to get to 14?
7, 2.
7 times 2. So it has other factors that aren't just 1 in itself.
But you could do 3.5 times 2.
So we're talking about only whole number factors. So when we talk about factors of a number, we just talk about whole number factors. Because otherwise there's technically like potentially infinitely many, especially if we include fractions.
Yeah.
Okay.
We're not doing that.
So no. Now if the number has to be greater than 1, can 0 and 1 be prime?
No.
No, okay? And then this other word that says composite. Composite just means it's not prime. So it's either prime or it's composite. It's one or the other. So if you want to write in there real quick underneath composite, just say, hey, that just means it's not prime.
You know,
There's
like,
composite numbers.
yeah, there's already a thing right above it. You just put it.
Oh, excuse me, a number that is not prime. Excuse me. Man, thank you. Woo!
I wrote it in pen.
That's okay, I wrote it in pen too.
Here's a pencil.
Okay, but you can go back and you can erase.
Yep.
I
Life
need
is
to
so
erase
unfair.
pen.
Oh my
Closer to
God.
colored
Very
pencil.
hard.
Okay.
I just want to cry in my bedroom about it.
Hey, so, yeah, thanks for catching that. I caught it when I filled out my notes here, but they're not here. Okay, questions on prime numbers and factors. You know, you might be wondering, Mr. Costle, is there an easier way to know if something's a factor of a number? Why, yes there is.
Divided by
Factor
2.
3.
So, here's some rules for divisors. First of all, if it can be divided by 2, it will be an even number. So that means if it ends in 0, 2, 4, 6, or 8, if it ends in an even number,
Or 10. It's
well, if it ends in 10,
divisible.
that means it ends in 0. So if it ends in an even number, it's divisible by 2. So did 72 end in an even number? Yeah, 72 is even, so divided by it. Okay? If for the number 3, if the sum of the digits is divisible by 2. Well, if we look at 72 again, what do we get if we add these two numbers together?
9.
9. It is 9 divisible by 3,
Yes.
so 3 went into it.
Can we use these rules on the, like, can we cut them out and then use them?
No, but they're good to remember.
Just make
I
it
encourage memorizing these rules.
Oh my God.
I
Okay.
memorized the factor 3.
4, the last two digits are divisible by 4. Now this doesn't help us with a number like 72, but if we get, that means if we have like 172, well the last two digits are 72. Did we say 4 went into 72? So 4 goes into 172, or 4 goes into 3,272. It goes into that as well because the last two digits are divisible by 4. Yeah, so as long as it ends with two digits that are divisible by 4, the last two digits are divisible by 4.
Why'd you skip
It's going to
7?
be divisible by 4.
And
Because there's no shortcut for 7. 5, the last digit here is either 0 or 5. We talked about that one. Hannah brought that one up.
What?
You brought up the
Yeah.
rule for 5. On 6, if it's divisible by both 2 and 3, it's going to be divisible by 6. If it's divisible by both 2 and 3, it's divisible by 6. Only if it's divisible by both. If it's only one or the other, it will not be divisible by 6. 8, Last three digits divisible by 8. Now it's not an easy one for us. That was not an easy one for us. That's okay. So this is going to be like a less common used one. 4 and 8 are going to be a little less commonly used for us than some of the others. 9, the sum of the digits is divisible by 9. Well, we said 7 plus 2 added up to be 9. 9 is divisible by 9. Yeah. Whereas if we have like, oh, I don't know, let's go 51. What do those add up to? 6. So is it divisible by 3? But is it divisible by 9? No. Because 6 is divisible by 3, but not by 9. So 3 would go into it, but 9 wouldn't.
So you need like a couple of rules because some don't work out. So like you should do.
So this one works out perfectly for 9, but this one it works out perfectly for 3. That's what that was showing. So because 6, 5 plus 1, 6 is divisible by 3, 3 goes into it 17 times. Whereas 9 will not go into it because these do not add up to be something divisible by 9. And that even works for longer digits, where if it was like, 1,825,
57. 2. 7.
7. What do those add up to be? 1 plus 8 plus 2 plus 7.
16.
18.
18.
Is 18 divisible by 3? 3 goes into it. Is 18 divisible by 9? Then 9 goes into this. 10 if it ends in 0. These are just shortcuts and rules that can kind of help us. I still go through these same exact rules when I look for factors. I go through these same exact rules when I go through factors. I just pop through them through my head and I say, is it even? Okay, 2. Do they add up to be divisible by 3? Okay, 3. Last 2 digits and a 4, okay, 4. And a 0, 5, 5. Divisible by 2 and 3, oh, it's divisible by 6 now. And I go through all of these. 8, not so much, because it's hard to remember the last 3 digits being divisible by 8. Okay. Now, the greatest common factor, we call it GCF. Have you guys heard of that before?
Yeah.
Okay, I believe you guys have a little bit in some previous math classes.
Gator, crocodile, fish.
Okay, the greatest common factor, or GCF, of 2 or more integers, is the greatest number that's a factor of both. It's the greatest number that's a factor of both. So if we look at the integers, for example, let's look at 10 and 5. 10 and 5, for example. Let's compare these two. What are factors of 10?
2 and 5.
Okay? 2 and 5. What else?
10.
That's it.
1 and 10. What are factors of 5?
5.
1 and 5. Any others? No, 5 is 5. Okay? So the greatest common one is 5. So we'd say, oh, the GCF is 5. But do they both have that in common? No, it's the greatest one they have in common. Not just the greatest total, the greatest they have in common, right, Jacob? Write this down. Thank you.
So you give us 2 numbers and we have to figure this out.
So like, what's the greatest common factor between x squared and x? Because x times x squared is x times x.
What?
X squared is x times x, and this is just x.
Times 1.
So like some factors of this, for example, would be x times x, so you just repeat it, and then 1 times x squared. Whereas this would just be 1 x. So the greatest common factor here would be x. X times 1 would be x. X times x is x squared. 1 times x squared is x squared. Just like if I were to have written 9, I wouldn't write 1, 3, 3, 9. No, I just write 1, 3, 9, because 3 times 3 is 9.
Can we write 3 times 3 just to make know?
If you're listing factors, if you want to do it that way, I would suggest writing it this way then. Like 1 times 9, 3 times 3, and writing it like that. If you're going to do that. But when we list them like this, we don't want to double. We want to list them once. So let's go back to our distributive property a little bit here. We kind of talked about that at the beginning. So I want you guys to go ahead and distribute on these two. So go ahead and do the distributing on those first two there, where it says distributive property middle of your page. So go ahead and do that, please. Okay, so Betsy, what did you get for the first one? 6a plus 12. 3 times 2a is 6a. 3 times 4 is 12. Questions on that first one? Ben, what did you get on the second one?
8x squared plus 10x.
Very good. 8x squared plus 10x. So we multiply 2x times 4x becomes 8x squared. 2x times 5 is 10x. Is that a little bit like what we just did last chapter?
Yeah.
Yeah. Okay, that's too bad. Okay.
That's the only thing I don't like about math. Is that like, because it all like builds on each other. So if you don't understand like a thing that we learned 2 semesters ago or something, then it like affects you now.
Yeah, that can be a problem. Is it does build on each other. But the nice thing about it building on each other too is if you don't understand it, it can give you another chance to kind of learn it as we do it again. So it's kind of both sides of that. So now we're going to look to use the distributive property in reverse. We're going to look to use the distributive property in reverse. And we're going to use that to factor polynomials. So the first thing we do is figure out the GCF, or the greatest common factor, of every term. Now we said that terms are separated by what in here? Like, where are the terms?
Like what they're separated by.
Yeah, what are they separated by? By here.
Addition.
The addition sign. Here, what are they separated by?
Subtraction.
Subtraction. Are they ever separated by anything else? No, just addition, subtraction, okay? So how many terms are there here?
2.
How many terms are there here? 2. Very good. So we're going to find the GCF of the terms. So here, 15x and 9. What is the greatest common factor that goes into both of them? If you're having a little trouble with this, you don't see it right away, well, here's what you can do. You can say, okay, well, 15. What are some factors of 15? 1 times 15, we know that. And then we have 3 times 5. Okay? So what are some factors of 9? 1, 3 times 3, and 9. So what's our greatest common factor here? 3 is our greatest common factor. It's the one they have in common. So what we do is when it says factor the GCF out of all the terms, when we say factor, we're really going to divide it out. Okay, so what we do is we're going to write in here, we're going to take the 3 that we're doing, and we're going to write that at the front of a parenthesis. Now what goes inside the parentheses, we take this 15x, and we divide it by the 3, because we're taking the 3 out, we're factoring it out, we're dividing it out. And so what is 15x divided by 3? 5x. So that means 5x goes in that first spot. The plus sign stays a plus sign, and then we take 9 and divide it by 3. And what is 9 divided by 3? 3. So that means 3 is the second spot. So this now becomes 3 times the quantity of 5x plus 3. And now it becomes 3 times the quantity of 5x plus 3.
But you want to leave it like that, right?
Now we want to leave it like this, though. So before, if we saw this,
You
we'd
just
want to make it into what we had here, right? If we saw this, last chapter we said, oh, well, we need to go to here. We need to distribute and make, 3 times 5x is 15x, and 3 times 3 is 9. And did we get the same thing? So last chapter, we want to get to this point. So this chapter, we're going the reverse direction. We're going the other direction. We do that a lot of times in math. We'll go one direction and say, okay, well, now how can we go backwards? Okay, we want to be able to go both ways in math. So here, we look to go the other direction. So and this is the way you can check your work. Because if we distribute it back in, we should get the same thing. If we get anything different, you get it wrong. Okay? That's an instant check. I like that about these a lot, is because you can instantly check your work. Because if you distribute it back in, we get anything else, you did something wrong. Now, so that's what we call factoring out. In the orange, that's what we call factoring out here. So we factored out a 3. We factored out the greatest common factor, that GCF. And so what he did was he took the 3 out in front, and he said, okay, this is going to be multiplying with everything inside, and he divided everything by that GCF. We just pick a random number, we picked our GCF. So on number 2 here, what would be our GCF? Okay, so Ben says 5. Does 5 go into 20? And does 5 go into negative 35? Okay, and can we think of anything bigger that goes into both of those?
7. Wait, no,
So 7 goes into 35, does it go into 20? No, but it's good to spitball those. It's good to look for them. And if one thing I encourage too, if you want to, feel free to write it out, like 1 times 20 and 4 times 5 go into 20. Okay, well, do we know 4 doesn't go into 35, 20 doesn't go into 35, so it has to be 5. And you can do this other one too. Say, oh, you can write this one differently, 1 times 35 and 5 times 7, just to show you the 2 different ways of writing it. So here we said our GCF was 5. So what number are we going to write in front of the parentheses? 5. Very good. Now, for our first parenthesis, how do we figure out what's going to go first in that parenthesis?
20 divided by 5.
You take 20y and divide it by 5. And we get what? 4y. Now here, what sign are we going to put between the two numbers? Minus, because that's what was here. It's still that minus. We didn't change that. Now, how do we figure out this number?
35 divided by 5.
We take the next number, next term, and divide it by that same GCF. And we get 7. So this ends up being 5 times the quantity of 4y minus 7. Now we could go back through and check our work and say, hey, what's 5 times 4y? 20y. What's 5 times negative 7? Negative 35. Is that right? Then we're done. We factored out our GCF.
This is way easier than this.
Yeah, I know. I thought this is so much easier.
Good. Questions on these first two? Okay, let's go to the third one here. So here we have,
no.
flip your page. Flip the page.
Of course, it has to get hard again.
How else would I make you cry if it didn't get harder?
I would call you to try hard.
Okay, so 12x squared plus 3x.
Because I'm all wrong.
Guys, voice it off, please.
And I'll be rude.
Voice it off. Thank you. 12x squared plus 3x. What goes into both of those? Derek. Okay, I heard 3. So 3 goes into both of those. What else? 3x. Do they both have an x that can go into it? Yeah, we're looking for variables too. So you'll take, to figure out the first parenthesis, we'll take 12x squared and divide it by what? 3x. So what's 12 divided by 3?
4x squared.
4. What's x squared divided by x?
Wait, say it again.
What's x squared divided by x?
X to the third.
Just
X
not
squared.
divided,
It's x squared, right?
just x.
What?
Oh my god.
Oh,
When
so
you're
they like
dividing,
that. Okay, got
You
it.
can subtract 2 minus 1 is 1. Goes on top.
Wait, so how do you get? Okay, so how do you get rid of the 2 on top? Like, how do you do that?
This, we divided. So here it's x squared divided by x. You get, they both have an x in common. So just like here we divided by 3, and you got 4 and a 1. We divide by an x. X squared divided by x is just x. You get rid of one of those exponents, and x divided by x is 1.
Oh, so it's 1x, but you just write x.
On the bottom, it's just 1, but on the top it's 4 times x, which is 4x.
Good question.
So it's just like last chapter if we did 12x squared divided by 3x. We had those last chapters, the same exact thing. 12x squared divided by 3x, and it becomes 4x. The exponent. So when you divide x variables with the same exponent, whenever you have that x squared divided by
Oh, so
exponent.
it's 2 minus 1, and then you just have the 1 left over.
Correct. Okay, Grace.
Okay, so since the 3's cancel out, you just put a 1.
On the bottom.
No, like the.
On this next one, let's
Yeah.
look. So let's take to the next term to figure out what we have there. we'll take 3x divided by, well, what's our GCF? 3x. And what is 3x divided by itself? 1. Not nothing, it's 1. We have to be careful. And so yes, Grace, you will just put plus 1.
Because if you take, because when you distribute, then you'll get 3x.
Exactly. And that's exactly the point. Is when we distribute it back in now, if we distribute it, so this would be our answer. First of all, first and foremost, this would be our answer. But if we wanted to check, we wanted to distribute it back in to make sure we got the same thing. 3x times 4x is 12x squared, and 3x times 1 is 3x. Whereas if we didn't have that 1, we wouldn't have the 3x anymore. So we have to include that 1. It doesn't just go away, because otherwise when we distribute, we'd get the wrong thing. Questions on that one, on number 3? Okay, so on number 4 here, what do we think the GCF will be this time? 3. I think there's more to it. Can x go into both of them? Okay. Okay, so this one has x squared. How many x's does this one have? 1. So they can't take x squared out of this one.
So just do y, x, y.
X, y. Okay, because this has a y and this has a y. So let's try this. So let's take 9x squared y and divide it by 3xy. What are you left over with? 3. So what happens here with our 9 and 3?
X to the second.
Or no,
Here?
it's just 3.
Where are you asking there should be a y squared, Hannah?
On your negative 15, where it goes.
Yeah. There's a y squared.
Okay. So then, wouldn't you bring that down then?
Here?
Yeah.
How many y's does this one have though?
None.
How many y's
Well,
does
if
this
there's
one have? 1. So how many do they have in common? Only 1. So like here on number 3, this had 2x to the second, this had x. So how many x do they have in common? 1. Yep, you can only do what they both have. Just like we can't divide this by both these by 12, because this doesn't have a factor of 12. We only take what they have in common. We're taking a greatest common factor, so we only take what they have in common, what they both have. So if we take 9x squared y, the first term, divided by our GCF, our greatest common factor, 9 divided by 3 is 3. X squared divided by x is, we did this same thing in number 3. X, so it's x. And what's y divided by y? 1, so we just have 3x. So for our next one, we take negative 15xy and divide it by 3xy. And I say, okay, 15 divided by 3 is?
Y squared.
15 divided by 3 is, thank you.
-5.
X divided by x is
1.
1.
So it's negative 5y.
And y squared divided by y is y. So this ends up being minus 5y. So this ends up being our answer. And if we were to go through and distribute it back in, 3xy times 3x would be 9x squared y.
It looks weird whenever you write two variables next to each other.
I take back what I said, it's harder now.
Yeah, no, it was easy on the ones where they were meant to be easy, and then now it's back to regular ones, and it's like, oh crap.
Okay. I want you guys to do number 5 on your own. I want you guys to do number 5 on your own. When you're done, raise your hand to have it checked. When you have, guys, voice is off. When you're done, I want you to raise your hand to have it checked, or raise your hand if you have questions to ask a question on number 5.
Oh
If you
no.
look inside the parentheses,
Oh yeah.
we see 1.
Easy.
Yeah, so what would that be? Here
Oh,
it
that'd
says.
be fun.
So we take out 2 more.
Yeah.
What would you take out originally? Does that make sense? This is
Oh, duh,
this.
yeah.
So if we take 2 out more, we would
Yep, you can do x squared, because this is x squared, this is x to the 4th. So you want to go the lowest one. So yeah, x squared would work.
So then there's no 2 there anymore.
Correct.
So then it's just x, y squared.
But you took away the x, remember?
Oh, there's no, so it's just y squared.
Yeah, but then can you take away another? Do they both have a y in common as well?
So you can just completely eliminate the first one.
Well,
Except for this one, it's just y.
There you go.
That's so confusing, I don't understand this at all.
Pretty sure I got this.
So it's just like
Here. So you got rid of all of those. When you take out, you have more in common for the numbers. 2 and 4. Those have something in common? Yeah, so what can we take out? Is that? So we can take out 2. So
Whoa,
we
whoa,
can
I see how you feel.
I've been waiting.
What happened back in kindergarten when we were just trying to learn like division and shit? I want to go back to that. Or just like not doing this at all.
That's how I
I can
Who's like doing that?
Okay, I should. I can't explain it.
Factor out.
Did you sleep during nap time at kindergarten?
Hey, let's just talk about this up here. Class, let's talk about this up here. The boys stop, please. We're gonna talk about this up here quick. Thank you. So, here, one thing I saw people doing, which is awesome, they saw a factor and they went for it. So what factor some people saw? Jacob, what was the first one you saw? For the numbers. What was the first factor you saw for the numbers? What did you try? Well, you wrote it. What did you write before you drew over it? Thank you. 10. And then other people, and then we had different combinations of variables where I saw one was 10xy. And so from there we said, okay, well 20x squared y cubed divided by 10xy, our potential greatest common factor, would be 2xy squared. So in our parentheses we had 2xy squared. And then we had 40 x to the 4th y squared, and you did that too, by the same GCF 10xy, and you got 4 x to the 3rd y. So it'd be plus 4 x to the 3rd y. Now we take a look at this and we say, okay, well, inside our parentheses, do we still have more that's in common? Do these still have more in common? Yeah, what do they have in common? The 2, they have a 2, they have an x, because this still has an x, this is x to the 3rd, so they still share an x, and they both still share a y. So what we can do is we can take out another 2, another x, and another y. So how you would do that, this step, yes, we'll talk about that. Okay, so how we'll do this step, because this is the way a lot of us went, if you do not take the biggest factor, then you can do this. Take 10xy, and then you can factor out another 2xy, and then divide it from here. So we'll take 2xy squared divided by 2xy, and end up with just what? 2xy squared divided by 2xy, and we end up with just y. Then we take 4 x to the 3rd y divided by 2xy, and we end up with just x, or 2x, 2x squared. And now, do these have anything in common?
No.
No, but we need to multiply these together. So 2 times 10 is 20. X times x is
2x.
nope,
Or x2.
x squared. Y times y is y squared. So if we look at this, what was our actual greatest common factor? 20 x squared y squared. So does it benefit us to find our biggest one first? Yeah, it's a lot easier to just find our biggest one first. So you got to be careful not to just say, oh, 10 goes into both, let's try that. But you want to do as much as possible. And how you tell on your variable, one second, how you tell on your variable how many to take is you say, okay, well, this has an exponent of 2. This has an exponent of 4. So which one of those is smaller? 2. So that means we can take x squared out. Look at our y's. This is a variable of 3. This is a variable of 2. Which one of those is smaller? 2. So you can take y squared out. So you want to look for, oh, how many do these have in common? Well, the most you can do is the smallest one available. Because you can't take more than what's here out. You can't take more than what is there out. Jacob, what are we asking now? Can I move my pen? Okay.
Can we do number 6 on that one?
I'm good.
I go to Mr. Carlson, nice to meet you.
What's up?
You never shook my hand.
On number 6, I don't remember what your name was.
My name was, I'm gonna sleep in really late.
Oh yeah. Nice to meet you. I'm gonna sleep in really late. I remember. Okay. On number 6, what would be a little bit different from number 6?
It's
How-
a trinomial.
It's a trinomial, very good word, very good vocab. It's a trinomial, 3 terms. So does that mean we have to figure out what's in common for all 3 of these?
Yep.
Yes.
Yes. You have to figure out what's in common for all 3 of them. Okay? Go ahead and try that on your own. Go ahead and try that on your own.
Oh, yeah.
Kind of the same process. When you're done, please raise your hand. So, do they all have to be? Ooh, tricky. So do they all have a B? Do they all have a B? No. So can you take out a B if it doesn't have one?
Oh.
No.
Also, are we good?
Sure.
I could make a good one.
It's
So
called-
do they all have a B in common? So can you take a B out?
Oh, yeah, yeah, yeah.
So you gotta put that back in.
Would this just be
Wait, so I just erased the B from the beginning part?
Correct. And then you put it back into everything else.
Oh.
What was your question? So let's be here. Is there a B in 25a squared? So can you take a B out? So you can't take a B out, but you take a 5a. So instead of being 5ab, make it just 5a. Okay. Should we
Also-
try that first one again?
How do you like, what are you talking about? How do you put it back?
So, well, so instead of taking it away, well, it's already put back in.
Oh, it already is.
Yeah, because you didn't take it out in the first place.
Oh, so I did it wrong, but I actually ended up doing it right.
Correct.
That's fantastic.
Here, if you take an a away from here, so you need to divide 15a.
If I were to do it that way, the B wouldn't be there.
Correct, but now we need to take out a. You didn't do that.
Huh?
So here,
Oh.
15ab, you need to divide the a out.
Oh,
So
so,
there's an a
so
there.
there's no, so there's just one A,
Correct.
and then there's no A.
Correct. Does that make sense? So it's fine. Yeah, so is there a b here? So can we take a b out? No, what do they all have in common? Yeah, so you take an a out. So you can do 5a instead of 5b.
Shut up.
Okay. What we're gonna do actually is class is about over here. Class is about over here. Listen up. Listen up. Thank you. I want you guys to do number 7 in your notes. I want you to do 6 and 7 for homework, and that's it. No other homework today. I want you to do 6 and 7 for homework.
I'll do 8.
Okay.
Drop it on the ground, I'll drop mine. Mine's touched the ground. I think you're over there. And I'm going.
How would I just be the middleman? Just in your case.
You know you just gotta go.
I'm not into that.
Remember, if you wanted to be in my study hall today, you have to come up and talk to me.
How far, how many sacks?
Back to what you gave Josh, I think.